One, can you uh, unmute yourself?
Yeah,
No one,
yes, Ed.
Yeah.
no,
I
start
think
now.
we should start now.
We can start.
Yeah, yeah.
So, sure. So, hello, audience and fellow students. I hope you all are doing amazing. Welcome to another exciting ML sessions with your host and host Noman. Before we begin, let me introduce the CodeCrafter Club, an initiative designed to foster a community where students can learn, practice, and refine their coding skills. Now it's my pleasure to introduce our guest lecturer, Atul Kumar. With over 15 years of experience in IT, cloud technology, and telecommunications, Atul specializes in software and system design across various sectors like retail, fintech, healthcare, and e-commerce. He leverages cutting-edge technology in MLOps, DataOps, DevOps, and the cloud to create innovative solutions. His expertise in implementation end-to-end solution enhance operational efficiency through the best practices like CID, continuous integration and delivery. So without a further ado, let's start. Over to you, Atul sir.
Yeah. Thanks, Numan, and hello everyone. My name is Atul, and I'm very excited to part of this session. And before we start, I just want to just let you know that like I want this session to be interactive kind of session, right? Where we
Mm-hmm,
would be engaging with each other, and
mm-hmm,
we would be you know uh,
mm-hmm,
talking about your experience as well, what you guys know, right? And also there would be
mm-hmm,
few quiz as well, wherein like I would be just throwing away
mm-hmm,
some quizzes, wherein like
mm-hmm,
you guys can answer your you know uh,
mm-hmm,
uh, uh, answer based on the questions which I would be asking, right?
mm-hmm,
So I think we can get started, right? And let me share my
mm-hmm.
screen, okay? And let me know once my screen is visible to you guys, okay?
Sure.
1 second. So what is the sharing option? Can is that okay? Yeah, okay. Sharing option. Yeah, this is the sharing option. Hmm. So why it's not showing me desktop one? Okay, this is the desktop one. Okay, and sharing my screen. Oh, close on to share screen. Once again, I need to make some changes in the system to allow. I think I need to drop again, and I will rejoin. It's asking me to quit and reopen. Okay, I'll
Sure.
be joining back again. Yeah. Can you hear me, guys?
Yes.
Okay, cool. Okay, so let me share my screen.
Yeah, we can see your screen.
Okay, you can see the PPT.
Yes, we can see
Okay,
it.
cool. Yeah. Okay, so today we would be discussing on the artificial intelligence and machine learning. What is the importance of artificial intelligence and machine learning in the real time applications? Okay, we would be talking about like what are the real time applications. Okay, what how the data plays in a very important role in developing in a right AI and ML models. Okay, what we would be also discussing about one case study of about riding apps, right? By riding apps, I mean to say Lyft, Uber, or Ola, right? We'll be also discussing about that, like what are the challenges when you develop some AI and ML application. Okay, how the data will play an important role, and what are the best practices around it. Okay, and we'll be also having some quiz session as well, wherein like I would be giving some quizzes, and I would be like to know your answers as well, right? And in order to make it an interactive, there would be a few other questions coming around here and there, okay, that would make this session more interactive and engaging. Okay, and in the last we'll have a Q&A session wherein like I would be taking up the questions from you guys, and I will try to answer that questions as well. Okay, hope that makes sense to you guys.
Yeah, sounds perfect.
Okay, cool. Okay, so okay, yeah. So before I start the session, I would like to formally introduce myself. So as Numan mentioned about me, that like about my experience and other things. So I'm Atul, and I'm having 15 plus years of experience in various domains, right? I've been working into the IT, I've been working into the telecom sector as well, right? And I'm also community builder at the Xtex, right? So uh, I have worked on various technologies, okay, starting from the cloud, DevOps, data, ML, and LLM. So for last 1.5 years, I've been working into the LLMs as well, right? So I work with a pharmaceutical company, which is in Eli Lilly, as a principal architect, and Eli Lilly is a 150 years old company based out in US, okay, which basically uh, uh, manufactures the medicines. Okay, so if you have heard about insulin and polio, so Lilly is the inventor of these medicines. Okay, also like I've worked with various product based companies, with the service based companies as well, and I've been working as an enterprise architect in these companies. So I used to take care of like how these solutions are being designed, like what are the best strategies to design these solutions. Okay, what sort of tech stack you need to you know you have to select, what are the right industry practices, what are the right security practices, what are the right compliance practices to make sure like your data is intact, your data is sanitized, your data is not getting breached. Okay, you are developing right models which takes care of all the data, which takes care of all the use cases and whatnot. Also, I am AWS Associate and Professional Certified, though I cleared this certification in 2017. And after that, I didn't, went into the certification side because I firmly believe that like uh, uh, your knowledge and your experience plays an important role than the certifications. Okay, so I'm not saying that like you should not go for a certification, you can go for it, but this is my personal opinion. So after that, I stopped doing certifications, right? And about my hobbies, I like to read a lot. I like to watch the technology oriented content, and also I love to share my knowledge. So I've been doing some workshops, I've been doing taking knowledge sharing sessions in other colleges, in the companies as well, right? And I recently started my YouTube channel as well. So I firmly believe that like education should be free to all, okay, so that people can learn and they can find the right direction to their career. Okay. Now, going to the next slide. Uh, I think there is some. I just missed that agenda slide. Yeah, okay, fine. So in today's agenda, we would be covering on we would be introducing about the or talking about the AI and machine learning, what exactly they are, right? Then we would be talking about the uh, real-time applications, right? What are the real-time applications? Okay, what are the different types of the real-time applications? Then we'll be discussing about like the importance of data, right? How the data plays an important role in developing the machine learning and AI models, right? And what is the data engineering? Okay, right? Because people talk about a lot of things, right? Like about the AI and ML and even about the LLMs, but they don't, talk about like how the data engineering plays an important role, right? Then we'll be discussing about like how the data engineering, you know, complements the AI and ML models, right? After that, we'll be talking about the case studies, right? The case studies, we'll be talking about the case study of a riding app, right? So, for example, Lyft or Uber, right? Then we'll be talking about the challenges and the best practices. And after that, we will be talking about, we will be taking some quizzes and, quick Q&A session, right? So, without any delay, let me start with the introduction of the AI and ML. Okay, so I would like you guys to just mention in the comments, right? Like, what do you understand? But if somebody comes to you and asks you, hey, tell me what is AI? Okay, or what is the difference between AI and ML? Okay, so what would be your answer in a very short and layman terms? So before I start discussing about AI and ML, any thoughts here? I can see AI is a field which deals with creating machines which behaves like human. Okay, ML is subset of AI. Good. Abhijit says ML is subset. Okay. What else, guys? Any other thoughts about AI and ML? No? Okay, fine. So let me talk about AI. Okay, so AI is a copy of brain. Santosh says okay. So AI is going to dominate many fields in the future. AI is a technology. Okay, good. Yeah. Okay. So see, if you want to understand as a beginner, okay, right? So what I think AI is, okay. So AI is a branch of computer science, okay. That basically that basically focuses on creating systems, okay, and that systems are capable of performing tasks, okay, that could typically require human intelligence, okay. So human intelligence, it means like, right, like if for example you are talking to somebody, okay, so that person understands your language, okay, you delegate some task to someone, okay, do this, do that, okay, draft an email, okay, or drive the car, stop the car, okay. So these are the some actions which somebody is delegating to you and you are able to understand that, okay, right? So this is something like AI is, okay. So AI basically understands like it recognizes the speech, it makes the decision, okay, it understands the various things, right, like understands the images, understands the videos, right? So AI allows computers to think, learn, and solve the problems in a way that humans do it, okay. So it's kind of it's mimicking the human behavior, okay. That is the AI, right? Now, when we talk about ML, okay, machine learning. So machine learning is a subset of AI, as Santosh mentioned, right? So it's a subset of AI, and it involves teaching computers to learn from data, okay, and improve their performance over the time, okay. without being explicitly programmed, right? So it uses the data to train itself. So ML algorithms find patterns in the large data and then they make the decisions. Okay, so this is the definition of AI and ML. Okay, so ML comes under the AI. Okay, so it's a subset of AI. Okay, now if we talk about the examples of AI. Okay, so I think you guys know about Siri. Okay, that is an inbuilt app of iPhone. Okay, so you can ask anything. Okay, Alexa, Amazon Alexa, you can give some commands and you can ask. In Android, it's Google Assistant. Okay, you can use your voice to give some commands to to delegate some task. Okay, for example, you ask Siri, okay, or Google Assistant or Alexa, hey, what is the weather today? Okay, so it's automatically it provides you the answer like today's weather is 23 degrees Celsius. Okay, what is the temperature in Chennai? What is the temperature in Bangalore? What is temperature in US? What is the traffic to this way? Right. So it understands your question. Okay, and based on that, it gives you the answer. Right. Wherein, if you talk about the ML example, okay, so any guesses now here, guys? Like what should be an ML example here? Any guesses here? You can post your comments on in the chat if you want. Any before I explain you like what are the examples? Pattern recognition, okay. Recommendation, good. Classification, super. Good. Ads on internet, wow. Weather predictions. Nice. So you guys are, I think you guys are aware of, news, fraud, new detection, chatbot. Okay. Wow. So a lot of comments. Okay. Good. A lot of answers. Right. Spam detections using classification techniques. Okay. Cool. So yeah, as you guys said, right, like so recommendation system, right, the spam detection and other things, right? So a common example here is the YouTube. Okay, so in YouTube you get the YouTube basically recommends the videos based on your watching pattern. Okay, like which all videos you are watching. Based on that, it gives you the it basically recommends you the movies or videos based on what you have watched before. So this is the machine learning in the action. Okay, so these algorithms learn from your viewing habit. Okay, which are things you are viewing. Okay, and it also identifies the pattern and recommends that content you enjoy watching it. Okay, so these are the examples of AI and machine learning, right? And in summary, like AI is like a brain that makes decisions, while ML is a method that uses or that learns from data and improves over the time. Okay, so these are the differences and the examples of AI and ML. Okay, so I will move to the next slide here. Oops, what happened? Okay, yeah. So now let's talk about the what do you say? Real-time applications. Okay. So what are the real-time applications here? Okay. So real-time applications are something like these are the systems. Okay, that need to process the data and provide the responses instantly. Okay, or at least really fast. Okay, right. So real-time applications are classified in two categories. Okay, one is the hard real-time systems and the other one is the soft real-time systems. Okay, so hard time real systems are like autonomous vehicles. Okay, so autonomous vehicles, I mean to say, I hope you guys have heard about Tesla. Okay, so Tesla vehicles are autopilot systems. Okay, so you just simply put the location where you need to go and the car will automatically take you to that location. Okay, you don't need to apply or you don't need to pull on the steering, and you need to no need to change the gears, no need to apply the brakes, nothing. It will automatically take to that location. Okay, so these are the hard time real systems. Okay, and the other example is the military equipments. Okay, so military equipments, I mean to say, like the missiles. Okay, so you want to test missiles, or in the war, like you have to put the location of that particular target, and that missiles will take care of it. Okay, and they will hit the right target, okay, on the right time, right? Then is the soft real-time systems. Okay, so the examples are the online games or the social media apps. Okay, right? So these are the uh, examples of the soft real-time systems. So we'll discuss about the hard real-time systems. Okay, so in hard time real systems, these are very critical systems. Okay, so there are no ifs and buts. Okay, if you miss a deadline, game is over. Okay, so for example, right, like you are in Tesla. Okay, you are in some autonomous vehicle, right, and it is not applying the brakes on the time. Okay, it may dash to some other vehicle. Okay, or you can get into some accident, right? Similarly is the military equipments. Okay, you have put in a target, right, but it is not hitting to that target. Okay, it's not hitting to that enemy target, it hit to some civilians place. Okay, so it can lead to casualties. Okay, so these are very, very critical systems. Okay, there are no ifs, there are no buts. Okay, if you miss the target, or if you miss the deadline, or if you miss the defined objective, right, it can create a problem for you. Okay, so in the business world, right, if you miss something, right, it can definitely impact your system. If your system misses, or if your system does not behave as per the expected behavior, right, this can lead to the loss in revenue. Okay, or it can also lead to the you know bringing a bad name to the company or the organization, right? So now one more question to you guys. Okay, so apart from these two examples, autonomous vehicles or the military equipments, okay, what are the other examples you guys think about the hard real-time systems? Any any other examples you guys want to share? I'm not able to go to the chats. Okay. Any other examples, guys? Smartwatches. Do you think like it is a hard real time systems? I don't see that. Okay, face detection. No. Insulin monitor. Okay. Autopilot drones. Autopilot drones. Voice to face making. So do you think that like these are the hard real-time systems? Okay, like no if and buts here, right? Like if you miss something, the game is over. Do you think like face detection, smartwatch comes under this category? Opening and closing doors, game is over in that. Okay. Voice to face making, automatic cars. So automatic cars come under this, autonomous system. Detection of bank frauds. Okay, that makes sense. Traffic control, yes, that's right. You are near to that. Face detection for authentication, like flip your head. Flip your head. Okay. Okay, cool. Fine. What do you think about the soft real-time systems? Soft real-time systems, apart from social media apps, online gamings, what are other examples of soft real-time systems, guys? because like the most of the examples which which you guys have shared, like they come under the soft real-time systems category, not into the hard real-time. Like there were few, but not all. Okay, ads, yeah, makes sense. What else, guys? Recommendation on the market, places like Amazon, email systems, yes. Mm-hmm. Mm-hmm. Streaming platforms, cool. Um, um, let's discuss about examples of some not the examples, the scenarios of the autonomous vehicles. Okay, so imagine you are driving a self car, okay, and you are driving at a high speed. Okay, suddenly some animal comes on the road, or it appears in front of the in front of you. Okay, so the car needs to decide faster than you. Okay, so here AI needs to win. Okay, so these are the very critical situations where the AI needs to make the decision quickly. Okay, if there is a delay of in the milliseconds as well, it can hit to that animal, or it can hit to the person, whosoever comes in between, right? So these are the critical scenarios, right? So the others, right, the one examples which you guys have shared, so that will not come under the category of the hard real-time systems, right? Now we'll talk about the soft real-time systems. Okay, so like I will take an example of uh, online gaming. Okay, so like like every person has a different opinion on this. Some people who are really die-hard fans of gaming, or like they're really crazy about the gaming. They say like, no, these gaming systems are also they should be classified as a hard real-time systems, but in actual they are not. Okay, so like if a person is playing a game where your character gets lag, okay, or walks in some other direction, or like it it does not behave as per the expected behavior, right? So this is not a life threatening. Okay, it's something like you can just quit the game, or you can reset the game, and you can good to go again, right? So that does not comes under the category of the hard real time systems. Okay, so when a system is right, like when a system is super responsive, we say it's a snappy, right? But if it is slow, so it's lagging like a turtle, right? So this is how that system works, right? So robotics. Mhm. So it depends upon like that robotics, what exactly that robot is doing. Okay, if it is doing some some non-critical work, yeah, definitely it can be classified as in soft rail systems. But if that robot is taking care of controlling the traffic on a super fast highway, then it is definitely hard real-time systems. Okay, so I hope we have now a fair understanding on what are the hard real time systems and what are the soft real time systems. Okay, yeah, cool. So I need to. I don't know why this is not moving. Okay, uh, yeah. I will move to the next slide. Okay, so now we'll discuss about the data now. Since you guys have the understanding about like what are the AI systems, what are the ML systems, what are the hard real-time systems, and the soft real systems. Now we'll discuss about the data. What is the importance of the data, right? Okay, so before I go into the data, okay, so tell me, what do you understand by data? What do you understand by data? What is data for you? You just post your comments in the chat. Information, good. Organized information, not exactly. Data is information category detailed. Okay. Data is info. Okay. Any group of information. Random information generated through an activity or a phenomenon. All right. Okay. So see, data can be anything here. Okay. Collection of the raw facts. That's good. Yeah. Description of our surrounding. Somewhere near to that actual description. From which we can extract something useful. Good. Sarthak, yeah, nice. Data is collection of organized information. Santosh, here I would differ with your, thought. Data is anything which we are interested. Nice, Ranshi. Okay, so yeah, so like the data is an information. Okay, so it's not like it should be in an organized way. Okay, so if you have heard about like structured data, unstructured data, semi-structured data, so it's not like it should be in an organized. Data can be any information. Okay, which is stored somewhere, which is placed somewhere, and how that data can be used to create a value out of it. Okay, right? So the definition of data is like data is an information. Okay, it can be in any format. Okay, it can be in audio, video, it can be in file formats, CSV, TXT, XMLs, JSON, and whatnot, right? PDF, Word document, and whatnot. Okay, so data can be in any format. Okay, it can be in a form of structured, unstructured, semi-structured, right? And now if you want to use, and now it depends upon the business and the users, right? Like how they want to use their data to get value out of it. Okay, few use that data to do some analytical things. Okay, some use for that data to create some good models out of it. Okay, so we'll be talking about the importance of the good data here. Okay, so there is a saying, right, like about the bad data, right, and the good data. Okay, so the bad data basically it leads to the bad models. Okay, and if you make a bad models, you'll make a bad decisions, right? Okay, so think of data as a fuel for your AI engine. Okay, so if in your car, if you put a bad oil, okay, or a dirty fuel in your car, okay, so it will start creating the issues. Okay, right? Sometimes your car would not start on time. It will start giving you the misses while changing the gears, or while you are driving the car, right? Same thing is applicable with the data and the machine learning and AI models as well. Okay, so it's like garbage in and garbage out. Okay, if you put garbage in, it will give you the garbage out only. Okay, so that is the fundamental behind it, right? Correct. So now one more question I just want to ask you guys. Okay, what what is the example for the bad data for you guys? Okay, since you guys are doing the AI and ML course. Okay, so what is the example for a bad data for you? What is the example? Okay, Shtab says when the raw facts are not actually facts. Good, nice. What else, guys? And also tell me about what is the good data then. Okay, too much noise on data in the data. Nice. Records with different sets of attributes. No, not exactly, Asta. Okay, data is something which is collected, analyzed. Good data should follow the principle of sanity of data, and bad data is something that does not make sense. For example, 2 kg of milk is not possible. Good. Yeah. And what are the examples of the good data then? bad data is that who make the negative senses. Okay, so tell me one question here. Okay, so uh, what is the one key characteristic of good data? Okay, so I will give you three options here. Okay, so one is it is always in binary. Second option should be it's accurate and relevant, and the third option, it's written nicely. Okay, second. Good. Okay, so now uh, now you guys know, right, that like uh, uh, what a bad data can lead to. Okay, like if you have a bad data, you will have a bad model because you are training your model with a bad data. Okay, so that garbage in and garbage out, okay, very much depicts to that statement, right? Now, why good data matters? Okay, why good data matters? Because this basically, if you have a good data, you'll create able to create a good models, which will able to give you the right predictions, right? Accurate predictions as well, right? Or the reliable outcomes it will give you, right? Okay, so if you have a good data, then it will have a right accuracy, it will have the reliability, it will have the efficiency, right? So models can be only be accurate if you have a right data from which it has been trained. Okay, and when I say reliability, okay, so the consistent data will give you a consistent performance here, right? Okay, so it will not put you in a zigzag situation wherein like, hey, I'm not sure, like it will always give you a right model. Okay, so it will have a consistent behavior, so this will give a business a reliability, okay, for that particular model. Okay, if you have a good data, right? And efficiency here, I mean to say, like if you have a good data or the clean data, okay, so it will take less time in training the model. Okay, it has already mitigated all the risk associated with that data, right? Like it has already done the standardization, it has already done the normalization. Okay, it has already removed the anomalies against the data and whatnot. Okay, so that is something which good data gives to a model. Okay, so feeding your feeding your model, okay, with the bad data is like uh, feeding bad fuel to your car. Okay, right? And if you ignore that fact, okay, you will always be running into the issues. Okay, and it will unnecessarily increase your opex. So opex, I mean to say the operational cost here. Okay, so this is where that as a AI and ML engineers, okay, you guys should closely work with the data engineering team. Okay, because data engineering team is very underrated teams. People say like, no, data science team does the actual job or the magic, but it's the data engineering team who basically gives in a platform to the data scientists and the ML engineers to create right models and fit the use cases for the business. Okay, does it make sense to you guys? Okay, so yeah, so now moving to the next slide. Okay, so as I said, right, like data engineering is a very much underrated thing in the industry. Okay, because if you don't have the right data, if you don't have the right engineering data engineering practices, best practices in place, okay, you will run into the issues every time. Okay, and the most of the and if you have heard about this thing as well, right, like most of the models, right, which are goes in the production, that get fails. Okay, that is the reason why they get failed. Okay, or they are not adding a value to the business because they don't know how to get the right data and how to train that models with the right data in the real time, right? So that is the reason wherein like the MLOps thing came into the picture, right? Or the automation of the model deployments, okay, automation of the real time training the models, okay, came into the picture and whatnot, right? So that is an altogether a separate topic we can cover in some other sessions, right? But let's go talk about the data engineering. Okay, what is the data engineering? So guys, do you guys have any idea on the data engineering? What is the data engineering? Any thoughts? You just post your comments in the chat. Any thought, like if by any chance you guys have any understanding on that? Okay, so what's this? Team who manages, no, I'm asking about the data engineering. What is data engineering? Not the data engineering team. Vishwas, okay, sorry. Any thoughts? Okay, managing and organizing data, good. Generating good data from raw data, yeah, good, Dipankar, nice. Okay, so practice of designing and building systems, nice. Access and manipulation of data. Asta, you're right, nice. Xiaomi, basically make a strategy on data. That is the job of data architect here. But data pipeline management, digging up the data from the data warehouse, not exactly on this. Preetham, entire pipeline. Okay, so let me talk about this thing. So see, data engineering is like, it's something building infrastructure, okay, infrastructure or a platform, okay, that can collect, that can store, and that can process the data. Okay, so for example, you have your data stored somewhere in your drives, okay, NFS drives, okay, or it's stored somewhere on your laptop, or it's stored in somewhere on a drive on a server, okay, and you don't know what is that data is, okay, you don't know about it's like what is the format of that data, is it a structured data, unstructured data, and whatnot, right? But you want to get a value out of that data, okay, so that process will include bringing that data to an ecosystem, okay. So by that ecosystem, I mean to say, and mostly all the data engineering platforms are on cloud here, okay. There are other reasons for it, right? Like the scalability is one of the reasons, right? Because the size of data varies from business to business. Some can have in GB, some can have in terabytes, some can have in petabytes, okay. So it depends. So you need to have a very scalable ecosystem or a platform. So cloud suffices that need, okay. So by cloud, it can be AWS, it can be Azure, Google, right, and whatnot, right? So bringing that data to that particular ecosystem and storing that data in a raw zone. And once you store that data in a raw zone, okay, from there you start doing the data engineering practices, right? By data engineering practices, I mean to say ETL practices, okay. So that means extract, transform, and load, okay. So it is extracting it, it is transforming it, and loading it to the right data warehouse, okay. From there the business can do the they can do the analytical things, they can do the model development things as well, okay. So this is what data engineering is doing in the real time, or not the real time, I would say. I would in the industry, right? This is how it does, okay. So now we'll talk about like what are the different steps in data engineering, okay. So one of these step is like data collection, okay. So data collection is something wherein like the data engineers, right, they gather the data from the various sources, okay. So sources can be anything here, right? Like it can be in a SharePoint site, it can be a Salesforce site, it can be in a Viva Vault, it can be some drive, it can be some in-house servers and whatnot, okay. Or it can be a local system as well, okay. Social media, yeah, there you go, okay. So all there can be multiple data sources, okay, different types of data sources, depends upon business to business, okay. And also data engineer make sure that like the data which is collected, okay, it is in a usable format. Okay, so they see whether if the data is not corrupted, okay, the data is not in a format which is which can't be used, okay, so they do the data parsing as well, okay, convert into desired format, okay, so that the data can be used by the business. Okay, so this is the data collection. Okay, right. The second thing is the data processing. Okay, so by data processing, what I mean here is like cleaning and transforming the data. Okay, so by cleaning and transforming, I mean like removing the duplicates entries. Okay, there can be missing values in the data, right? And there can be what do you say, wrong entries as well, right, in the data, right? And that needs to be fixed, okay, by the data engineers. Okay, so they create the data models out of it. Okay, they make sure like there are no, you know, duplicate entries, there are no, you know, missing values, right? So the data engineers you know, create these scripts, Python scripts and whatnot, to make sure like your data is up to the mark here, right? Okay, now comes like after all this process is done, right, you have collected that data, you have processed that data, then it comes like how, where the data would be stored, okay, so that it can be easily accessed by the business. Okay, right. So one more question to you guys, okay, about the storage, right? So what are the various storages, okay, where the data can be stored? Any thoughts around here? Cloud storage, good. Will not go with the local storage, guys, because local storage, as I said, right, in the local storage, you're not able to scale your, you know, this platform. Okay, if it crosses a certain limit, okay, right. For example, your local storage is capable of storing 100 GB of data, and if goes beyond that, so you'll run into the issues. It's not scalable. So cloud is, yeah. So in cloud, what exactly in cloud? Okay, and because in cloud there are other things as well, right? Like you have the object storage. Okay, so object storage can be an S3 and a blob storage and a Google Drive. It's a part of the object storage. Database, yeah, that's right. SD card, no, no. SD card, no. Repositories, no, not exactly. Quantum computer stores largest amount. Quantum computer is a separate thing. Okay, so let's not, you know, mix quantum thing here. Okay, quantum computer, quantum mechanics, quantum physics is altogether different thing here. Data lakes, yes, that's right, Sumanshu. Dipankar, Google Drive, yes, that's right. Okay, so yeah, file manager, not exactly. Okay, so as you guys said, right, like the data would be stored in cloud. Okay, it can be AWS, Azure, or Google, and data can be stored in object storage. So object storage in AWS, it's S3. Okay, in Azure, it is a blob storage. In Google, it is in a Google Drive, right? And if we talk about the databases, okay, so databases, it can be, you know, SQL databases, okay, NoSQL databases, right? So in AWS, we have RDS instances. Okay, so RDS is a SQL database. NoSQL database is in a DynamoDB, okay, in AWS, wherein you can store, right, the data, right? And data lake, yeah, Himanshu mentioned the right, term, data lakes. Okay, so data lakes are basically used to storing vast amount of data, okay, for the business use. Okay, data oceans, yes, that's right, okay. So this is where we store the data, okay, and from there the data is being managed, right? I hope we are good so far, right? You guys have an understanding about like what is the data engineering, okay? What are the various, you know, uh, uh, processes in the data engineering, right? Data collection, data processing, and data storing, okay? So if you guys are okay with it, I mean, like if you guys understood this data engineering concept, I'm moving to the next part, which is the data. Why the data engineering matters? Okay. So data engineering is basically, it is in a foundation for your AI and ML models. Okay. Or it is in a foundation for your AI and ML use cases. Okay. Right. So without a solid data engineering, right, your AI project is like a house built on the sand. Okay. If you don't have the right, data engineering practices in place, so your AI and ML project cannot suffice for a long time. Okay. Okay. And it will not have the efficiency, it will not have the scalability. Okay. Because you don't have the proper infrastructure, you don't have the right pipelines, you don't have the right process in place. Okay. So that can bring the uncertainty to your AI and ML project. Okay. So this is where the data engineering plays in a very important role. And data engineering is not only just to store, gather, and manage your data. It takes care of other things as well, right? It does your metadata management. It stores your metadata. It also what do you say, gives search capability, easily searching your data as well, right? So these are the things which are the bells and whistles for your AI and ML projects. Okay, wherein like you place your data properly, you process that your data properly. Okay, and then accordingly you can leverage that data for your analytics purpose or for your AI and ML use cases as well. Okay, right. So now one question to you guys. Okay, so you just tell me this thing, like, which is not the responsibility of the data engineering? Yeah. Okay. So three options. So one is the data collection, second is the data modeling, and third is the designing the company logo. So what, which is not the responsibility of data engineering? Oh wow, Sarthak, right. I think this was a simple one. Okay. Okay. Fine. Nice. So yeah, cool. Okay. So I think you guys are clear with the data engineering concept here, and why this matters to the your AI and ML projects. Okay. So now I will move to the next slide. Okay. Which wherein like we will be talking about how the how data engineering complements AI and ML projects. Okay. So as you know that data engineers build the pipelines. Okay, and the data scientists and the ML engineers build the models. Okay, so now one question here before I go deeper into it. Okay, what is the difference between the data scientist and the ML engineers? Both are building the models, but what is the difference? Scientists are the ones who, okay. Mm-hmm. They drive conclusions, need good communication skills. Not exactly. Communication skills are needed for everyone. Good one, Himanshu. AI ML is for algorithm. Mhm. Mhm. Thanks, right. ML use data for the applications. My question was more on the, what is the difference, what are the difference, what is the difference between the data scientists and the ML engineers, not the data engineers. Okay, data engineers, we know that what data engineers are doing, they are building the data engineering pipelines. Okay, which basically take care of your extraction, transform, and load. Okay, ETL operation or ELT operations. Data scientists mainly work in the development of the model, whereas ML engineer works on the production deployment of the models. Yes, there you go. Asta, yes. You are very near to this. That's right. Okay. So yeah. So data scientists are basically the people who understand the business requirement. Okay, like what is the use case for that business? Okay, right? Like business says like I want to create a model which can do a forecasting for me. Okay, so that data scientist will work closely with the data engineers and it will tell them like, hey, these are the features I need to extract from the data to build a model. Okay, so the data scientist will let them know that data engineers like these features I am looking for and these features needs to be extracted. So accordingly data engineers will modify their scripts and they will get that feature extracted out of it, right? Wherein that ML engineers will make sure that model is seamlessly deployed to the production, which is the case in the industry. Okay, question from Bilab is, are the data scientists are like a product owner? Not exactly. Product owner is something like who takes care of full product, okay? Right, if you're developing an application, okay, so what is the roadmap of that application? Okay, what sort of features they want to build? Features, I mean to say the capabilities they want to build, okay? So data scientists work under the product owner, okay? So product owner will be talking to the different stakeholders into the organization. They can be the business owners, they can be the architects, they can be the testers, they can be the developers. I mean, like developers, I mean to say the development leads, okay, the testing leads, okay, the scrum masters, the business owners, okay, business owners, I mean to say the clients, okay. So they cater the full requirements, they define the roadmap of that particular product, and the data scientists, the data engineers, the ML engineers, the testers, the developers, okay, the infra engineers all work under that product owner, which help in facilitating this seamless product development. Okay, right? So this is something uh, data scientists do and the ML engineers are doing, right? Now, for example, I will talk about an example. Okay, so like for example, a real-time fraud detection in a banking system. Okay, so what data engineers are doing here is, okay, so they are capturing that particular data, the transaction data. Okay, that happens. Okay, right? They capture it, store it, process it, store it, and place it. Okay, now the AI and ML team, okay, which includes the ML engineers, which includes the data scientists as well, they are going to analyze that particular transformed data. Okay, they analyze that data, okay, and they understand that various patterns, okay, and based on that patterns they start developing their own scripts, okay, that scripts which will help them in detecting that suspicious patterns, right? And this is where the models are being developed, which would be detecting any suspicious, okay, or any fraud which is happening into the banking domains. Okay, so now what is the importance of the good data in the real time here? Okay, again, like as I said in the previous slides, that like it will give you the more accuracy, it will give you the provide you the speed as well. So real systems can't afford the delays or can't afford the mistakes. Okay, if there is a single mistake or a small mistake, you are gone, right? So this is where the good data will play an important role in the real time. Okay, so it's a job of all the members in a team. Okay, it's not only the job of the ML engineer, it's not a job of the data scientist which is going to take care of the models and whatnot. It's a job of the data engineer as well. Okay, it is a job of the product owner as well, it is a job of the ML engineer, it is job of the data science. All work together to make a right models. Okay, right? And also last but not the least here in this thing, that data quality. Okay, so data quality matters a lot in your any ML and AI project. Okay, so if you have a good data quality, okay, so which will ensure that your AI model makes the right call when it matters the most. So it's not like that, like, okay, I'm compromising with the data here, okay, or the quality of the data. Okay, it should be 97% of the data quality, but I'm going with the 90%. No, you can't do that in the actual IT industry, right? There are some threshold defines. Okay, there are some parameters configured against each of the data quality. Okay, and based on that, um, the decisions are being made. Okay, right? So this is where this data engineering complements with the your AI and ML use cases. Okay, right? Yeah. Okay. So one more question here to you guys. Okay. So in the real time systems, okay, what is the crucial for effective AI and ML performance? It is the three options, right? One is the fancy user interface. Second is the high quality or fast moving data, and the third one is the colorful server racks. So I will repeat the question again. In a real time systems, what is the crucial for effective AI and ML performance? It is in some fancy UI, or it is some good quality data, or some colorful servers. Okay, good. Second. Yeah, cool. Fine. So now we will talk about uh, use case here, or not the use case, a case study. We are going to talk about a case study here. Okay, so that is something on the riding apps. Okay, like Uber or Lyft. Okay, so you guys, I would request you guys to think like as an entrepreneurs here. Okay, or someone who wants to start a company, or wants to not start a company here. Okay, you you guys wants to build an application. Okay, that would be similar to an Uber or Ola or Lyft. Okay, so tell me like what sort of things you will keep in the mind, okay, while designing this application. In this slide you can see like there are things mentioned, data engineering and this AI ML things, right? But like how you would I just want to know key points only. I don't want the detailed description here, only the key points, like how you will be start developing that application if you want to build your own Ola Uber application. Okay, so after that, I will just start on explaining, because this is going to take time. This thing, that this case study, and I will give you an example. I will start with the examples only, like how it happens. Focus main features first. I will add dynamic pricing. Focus on the main features. What else, guys? Target audience. Okay. We should create a unified interface which will organize the travel data and trends, and maintain an organized repository. Traffic monitoring. Okay. Tool. Good communication with the audience. You think like a technical person, right? Like how you are gonna start working on it from the scratch. Okay, what sort of things, like you guys are working in a team. Okay, let me make more precise to you. Like you are 2-3 people. Okay, and they want to develop Uber kind of an application, or Ola kind of an application, or Rapido kind of an application. Okay, so how you can do that? What are the key things which you guys need to keep in your mind? Okay, so okay, so okay, all right. So let me, I will explain you in a form of a story here. Okay, right. So there, let's think about that. There are few friends, okay, and they are chatting with each other, and they see like, okay, like let's uh, develop something, kind of online Uber apps. Okay, so these friends found themselves, right, frustrated with the city's congested traffic. Okay, and the unreliable transportation. Okay, with the Ola and Uber also, you see that there are a lot of issues. Okay, so they think that okay, fine, let's build our own something, right? Like that, like if you have heard about the Blue, the taxi service Blue. Okay, so they have built their own this taxi app. Okay, they have their own cars. So they also want to build similar to this Blue, right? Okay, so now these guys want, they don't want to create an app that basically connects riders and drivers in the real time. Okay, so they want it to make it more efficient and hassle free. Okay, so now they want to see like how this application would give them a precise location, connect with the right rider. Okay, connect with the right passenger. Okay, provide them the right location. Okay, and provide with the right information as well about the rider information, weather, traffic, okay, and whatnot. Okay, so now to start with, they need to lay a foundation here. Okay, so if you want to lay the foundation, okay, so this thing is to understand the challenge here. Okay, to understand a challenge, so they need to build a app which is not just about the creating a user interface. Okay, it's not about the creating the user interface. Okay, it is something which in the back end will process the real time data for thousands of users, for thousands of riders. Okay, and making sure that they match them efficiently, predict the right arrival times, and collecting or not collecting calculating the fare prices as well. Okay, like in the peak times, the prices, sometimes you have noticed, like in the peak times the prices are high. Okay, or in the normal times the prices are less. Okay, right. If you talk about the Bangalore traffic, in the evening you hire a cab, Ola cab or Uber, the prices are very high. But if you go in the afternoon, the prices are less. Okay, so it adjusts it's dynamically. Okay, right. So now to make this all things in real time, right, like it should capture all the GPS coordinates in the real time, process them efficiently. Okay, predict the arrival times. Okay, and also calculate the right prices as well. Okay, so that is something which that application needs to take care of it. Okay, yeah, that is also right. Shortest path, taking weather, distance, and traffic into the considerations. That's right. Okay, so now they understood the challenge here. Okay, the challenge is like capturing all the GPS coordinates, calculating the shortest path, weather, distance, traffic, and calculating the price. Right. Then how they can do this? Okay, this is where the data engineering comes into the picture. Okay, so the data engineering or the data engineer, what they are going to do here is, okay, they are going to build reliable, okay, or efficient data pipelines. Okay, okay, right. So what this thing they are going to do here is, okay, if you remember, I told you, right, like the data engineers are doing three things here. Okay, collecting the data, processing the data, and storing the data. Okay, so the first part is collecting the data. Okay, so now this data engineer would basically integrate or develop a data engineering pipeline that is gonna integrate the GPS functionality into the driver and the rider apps. Okay, which basically will bring that coordinates and store into a storage, okay, and it will do all the transformations, all the it will clean the data, it will standardize the data, it will normalize the data and whatnot. Okay, so this is what like it is going to do that. Okay, right? And then after it is done, right? So then the data transmission happens here in this use case. Okay, so it will basically ensure that your data is sent securely and quickly. Okay, they use a encrypted communication channel. Okay, so this is something you guys missed here, right? Like that the data which is moving from one platform to another. Okay, so that data also has some CI and PI information as well, right? So CI and PI, what do you mean? Okay, one more question here. So what do you understand by PI and CI here? PI and CI. I don't know. Okay. Kostov does not know. Okay, no worries. Fine. How about others? New to us. Wow. No? Okay. So PI stands for personal information. Okay. And CI stands for confidential information. Okay. So now what are the examples of PI and CI? Okay. Tell me. Examples of PI and CI. PI, religion, race, this, no. PI, personal information. Yeah, name, yeah. There you go. Age, height, weight, address, Aadhaar, bank, yeah. There you go. So now you got an understanding of like PI and CI here, right? And now you understand the importance as well, right? Like how you need to make sure like this information is encrypted. Okay, it should not be transmitted in encrypted way. Okay, because it can lead to the various compliance issues. Okay, in India there are no such data privacy guidelines. Okay, the government has started making it, but in other companies there are very strict laws for it. Okay, right? We have HIPAA, we have GDPR in the Europe. Okay, so these informations are very critical. Social SSN number in US. Yeah. That's right. Okay, so these are very critical informations. Okay, and they have a classification for it. Okay, they have a classification for it. Okay, the companies classify them as an red data, as a yellow, as a orange, and as a green. Okay, so by green I mean to say that data which is publicly available. Okay, you can go and check on the internet, that is publicly available. Okay, red data is like social security number. Okay, your bank account number, your Aadhaar card. Okay, these are the red data. Okay, which can't be shared without the user's consent, right? If you have heard about like if like the Facebook running into the issue, TikTok running into the issue. Okay, even Google run into the issues. Okay, because of breaching the users privacy policies. Okay, so these are the things which companies needs to understand. Okay, or even the architects, right? They need to understand that like, hey, how to secure this information. Okay, so this plays in a very important role in the ETL pipelines, right? Or the data engineering pipelines, right? Okay, now they collected the data engineers collected the data, they did the transformation of the data, placed somewhere. Okay, now the teams these guys started facing some issues with the data volume. Okay, because the volume of the data was very high. Okay. And with thousands of users, okay, or thousands of GPS coordinates, okay, or lakhs of the coordinates, okay. So the servers needs to scale horizontally, okay, right? And if they want to scale horizontally, they need to add more servers around it, okay. So by servers I mean to say storage here, okay. And servers will also be added as a part of the storage as well, okay. You need to mount the volumes on top of the servers, and then you can scale your servers, right? So as I said, right, in-house platforms, right, like if you have an in-premise servers there, you can't scale in the real time, okay. You have some limitations, okay. If your server has 500 GB of storage, you can't go beyond 500 of GB. But wherein if you are using a cloud solution, you can scale as much as you can, okay. So this is why the companies prefer to have their their workloads running on the cloud platforms, okay. So they selected some right cloud platform, AWS, Azure, Google, up to them, okay, based on the technology, based on their comfort zone, based on the pricing, based on the compatibility, based on the what do you say, uh, uh, um, right integrations with their third-party tools. So they went with a cloud platform that can handle the fluctuating loads and ensuring the smooth data flow within the platform, okay, right? Now, they after they have a clean data and everything, then they want to develop an algorithm, okay. Like what would be the right AI powered matching system they want to develop, okay, which would, wherein like it would have the proximity thing, that algorithm will provide drivers closest location of the rider, okay. So what that means here is, right, that this AI algorithm will automatically find which rider is near to that particular passenger or that user, okay. Once a user logins into the app, okay, and the rider is also already logged into that particular application, right? So you want to go to some place, right? You put your location, like, hey, this is my pickup location and this is my you know uh, destination, right? So from your pickup location, that ML model will basically calculate which is the nearest what do you say, rider available, okay. So how it is going to do that, it is only going to do this when it has the right data in place, okay. And with right data, it will have a right model trained to it, okay, which will give a very precise location based on the GPS coordinates, which it initially was ingested in your cloud platform, and then the data engineers did the all the extraction, transform, and load, and by that model was trained. So it will give them a right proximity, right location of that particular user and the rider, and the booking will be made, okay. Now this model will also do some additional things as well, okay. It will give you the driver's rating as well, okay, that hey, this driver has 5-star rating, it has 4-1 whatnot, okay. What is the vehicle type it has, okay, right? And how much would be the fare, okay, if you are going to this direction or that direction, okay. So this is something that model would take care of it, okay. And how this model would be developed, it will be developed by the use by the features which data scientists will tell data engineers to extract out of it and use that particular um, data or the features data to train that particular model, okay. So once that model is created, okay, it has an AI flavor on top of it. It will provide all this relevant results to the users who is going to book that particular ride, okay. Okay, there is a question. The machine learning model should not be biased. For example, drivers should not be given less or more passengers based on the race, gender, which lies on the quality of data of engineers. Yeah, absolutely. That's right. That's right. This is also, privacy, right? How you are, securing that particular information, and which you are not exposing to the rider and to the user. Okay, nothing related to the religion, nothing related to this thing, but the name should be reflected. Okay, the name of the customer and the name of the rider. Okay, so this is the right practice. Okay, you have to share the name of who is the rider, who is the passenger. Okay, right. It's not shows the name of the it doesn't it's not showing the religion name, or it's not showing the gender, it's not showing the race, but it's showing the name. Okay, so people predict this thing, or not predict, I would say, they come to know based on the name, right? Like, if somebody's name is Atul, okay, they will able to make it, right, that this rider is male. Okay, somebody's name is Kiran, or some female name, so they will able to understand that, like, that, hey, this rider is female or this is male. Okay, right. So yeah. Okay, so I think we are good so far, right? Like, how the data has been, data engineering takes care, and now how the data scientists and the ML engineers are creating the models, and then they are deploying into the production. Okay, now, not deploying in the production, they are going to deploy, because they need to test it first in the dev environment, then into the QA, and then take it into the production. Okay, so now they would be there is another challenge here, is like predicting the arrival times. Okay, how this challenge can be sorted out, right? Understanding the ETA challenges, right? Estimated time of arrival. Like, okay, so riders want to know exactly when their driver should arrive. Okay, right. So this thing would what all sort of things are needed here, right? There are some here they would be needing the current driver location. Okay, the traffic conditions, and the historical travel times as well. Okay, how much time it took generally from this route. Okay, and what is the current traffic condition right now. Okay, what is the current location of the driver's location. Okay, so that's using these data inputs, the model basically provides you the you know ETA of it. Okay, so tell me one thing here: which kind of model would be used to predict the arrival times based on the factors which I mentioned, like travel location, traffic conditions, and the historical travel times? Which kind of model can be used? Random forest. Okay. What else, guys? Mhm. How about the regression models? Mhm. Okay, so it depends. Okay, Exeboot. Okay, wow, AWS native thing. Pritam, nice. Mhm. Mhm. Okay, so it depends. Like, there are a lot of types of models into the market, and depends upon a user to user and business to business, like which model would be the right choice. Okay, so we'll go with the regression model here, like that can predict the arrival times based on the the factors which I mentioned about, right? Okay, so now this model needs to be tested regressively. Okay, this model needs to be tested repeatedly. Okay, so based on that, it will based on the testing, they will come to know whether the accuracy has been improved. Okay, the predictions have been improved or not. Okay, and once they have that threshold met, okay, that particular criteria met, they will be good to go, or they would good to conclude about that particular model. Okay, like, hey, this is the right model to provide you the right, ETA times. Okay, fine. So now, sixth thing would be how the app would be navigating the dynamic pricing here. Okay, which I was talking about, right? Like in the peak hours time, the prices are higher. In the normal times, it would be lower. So what are the various factors here? Okay, so it's all the high demand and high prices, right? The all demand and supply change. Yeah, that's right. So supply and demand game is here, and theory is here, the economics theory, right? So now, during the peak times on busy areas, prices are increased slightly to encourage more drivers to log in at that time, because they also need to motivate their drivers to be available during the peak times, right? It's not only sometimes riders complain, right? Hey, it's too the prices are high during the peak times. Why they are high? Why they are not normal? Okay, but again, like they also need to balance the equations between the riders and the drivers, right? So they have to increase the price to motivate the drivers to be available during the peak hours time. Okay, because they also don't want to go into the traffic unnecessarily. Who wants to go into traffic? Nobody wants to go into traffic. Okay, they would say, okay, I will go when the traffic is less. Okay, but to motivate them, they increase the price slightly. Okay, and when the during the quiet period times, right, like when there is less traffic, prices are less to attract more riders. Okay, they they have to again balance that thing. Okay, so the riders will go, okay, fine, okay, I will not go into peak hours time. Only the person who needs to, like, they are leaving for the office, or they have some urgent work, they only will take during the peak hours. Okay, in the normal times, like, first people will think, okay, like I will go in afternoon, okay, when the traffic is less, okay, I will go. So at that time you will be charged less. So that is just balancing an equation here. Okay, so this is a strategy played by the companies, okay, just to keep a balance between the riders and drivers. Okay, now using this technique, okay, or using this strategy, the model basically changes the prices. Okay, like in the peak hours time, this much would be the price. In the quiet period times, this would be the pricing. Okay, now the seventh point here is like ensuring the quality and trust here, okay, in the application. Okay, so how this thing would be done? Okay, so this is where, like, we would be emphasizing the importance of good data here. Okay, so now uh, the validation would be done. Okay, so validation here, like the teams would be basically implementing a check to correct to catch incorrect or unusual data. Okay, there might be sometimes, like, there would be some wrong GPS coordinates are coming. Okay, if you have used Google, right, sometimes it gives a wrong location sometimes. Okay, because that is also an application, okay, that works on a backend systems. Okay, it can also make a mistake, right? So in the real time, you need to always quickly validate that particular information, right? If you are booking some ride, okay, and that rider is standing some other place, okay, so then you will be talking, hey, my house is here, okay, you need to come here. Rider will say, no, I will not come, this is the location which this app is showing, I will not come here. Okay, so there would be a conflict happen between a rider and driver, okay, which will bring a bad name to the company. Okay, so just to avoid all this kind of situations, this validation needs to happen in the real time. Okay, so this is the one of the key things which the company needs to do, right? And then again, cleaning of the data, okay, in the real time itself. Though you have a model ready, but you need to keep on repeating this exercise to do that, right? So regularly purging that duplicate and outdated data. Okay, this data is outdated, or we have new data available. How I can use that data to train my model to get the accurate location, or get the accurate um, uh, uh, results for my rider and the driver. Okay, along with this, trust also matters, right? We talked about CI and PI here. Okay, so encryption. Okay, so all sensitive information needs to be encrypted in transit and at the rest. Okay, so once we have this thing in place, right, like we have right encryption and things in place, we would have trust build with the customer, okay? And we also need to provide them access control, right? Like only the authorized members can access the user and restrict the protocol, okay? I mean, like, it's not like any user would come and simply can access your data. So this is something like companies needs to build that trust between the customer and the users as well. Okay, there is message. Okay, okay, yeah, fine. So I think we are running out of time now. So fine. I think this was the the last point only, the seventh point. Okay, building the trust, and like you need to encrypt all your data in transit, right? And by considering all these points, right, users or the riders or the companies will make sure that you are have right application in place, with the right data, with the right application and the platform in place. Okay, so this is where a right application can be developed from the scratch. Okay, so I think I am good with now, and we have already talked about the challenges and best practices since we are running out of time. So data quality issues, which I discussed, scalability is the concern, okay, and the latency and the security compliance. So I think these are the things which we already discussed in the conversation. So I will not go into this again, right? And the best practices, which I've already talked about, like invest in your data quality, right? Choose the right tool, okay? Do a continuous monitoring and collaborate with the different teams to make sure, like by collaborating with different teams, I mean to say, like work with the data engineers, work with the data scientists, ML engineers, product owners, okay, testing team, development team, infrastructure team, right? So the team needs to work collaboratively with all the people, okay? Then only the right application or the right tools can be developed, okay? Fine. So we'll go into the Q&A session, okay? So I'm open for the questions. So yeah.
Yeah, what amazing sessions. The question is never end. So yeah, we'll start from the questions. Let me see how many questions we got. Mm.
Yeah.
So yeah, first question we got, can AI be effectively integrated into medical diagnosis for improved accuracy and efficiency?
Yes, absolutely, absolutely, and that is very interesting question here. So AI is playing a very important role, okay, in like easily discovering the molecules. Okay, so if you discover a right molecule, okay, right, you'll more easily able to develop a right medicine. Okay, correct.
Mm-hmm.
How it can be
Yeah.
done? It can be done when you have the right research data or clinical trials data. Okay, if you have right clinical trials data, you can develop a right model which will
Mm-hmm.
basically find the right molecules. Okay, and
Mm-hmm.
finding right molecules, okay, the sooner you find the right molecule, the faster you can develop a drug. Okay, so AI is being very much used in the health industry these days. Okay, and there is a very long way to go, but yeah, it has started showing its value to the healthcare industries as well. Make sense?
Amazing. Yeah, totally makes sense. I agree. And I think there's so many open sources building so the in the UK, I guess. So yeah.
Yeah.
So the another one is, what skill set should student develop now to thrive in the revolutionary AI ML advancement over the next 4 years?
Good. Yeah. Okay. So I would say, like, this is my opinion. Okay, and this is my thought here. Okay. So anyone who wants to, go into the AI and ML field, they first needs to understand the importance of the data. If they understand the importance of the data, right, like how the data can play a vital role for their AI and ML model. Okay,
Mm-hmm.
they can be a super AI engineers or ML engineers. Okay, it's AI does not means like developing an algorithm. Okay, or ML does not means developing an algorithm. Okay, there are a lot of open source tools, right, wherein like people can come and create then a wrapper on top of it and create a
Mm-hmm.
model out of it. But if somebody understands the data, right, hey, what type of data model I am using? Okay, what type of data I have? Okay, whether it is structured data, unstructured data, okay, semi-structured data, what should be the right format of that data? Okay, how I can transform that data, how I can normalize that data, how I can clean that data. Okay, if they understand the language of the data engineers, right, they can be in a good uh, AI and ML engineers. Or I would say, like, if in a long run, okay, a person will be never be acting as an engineer. Okay, they will have their own career progression, right? Engineer,
Mhm.
senior engineer, after that architect, then the enterprise architect, right? So if you want to be an enterprise architect, right, so enterprise architect is a role which is that role, like in these days, right, the companies are preferring the enterprise architects as their CTOs. Okay, now the managerial roles are getting obsolete. Okay, the companies don't want the managers. Okay, people managers here, because AI can take care of it. Okay, managing the resources. They want somebody who understands the technology. Okay, they want somebody who understands the business problem and can solve using the technology here, right? So to be an enterprise architect, a person should into the AI and ML field, they should understand the language of the data engineers. Okay, so this is my opinion on this answer to this question here.
Cool. Makes sense. So another questions we have, what initially inspired you to become a working professional in the AI/ML field?
Oh wow. Oh, how to answer this? I don't know. Okay, so see, I started my career as into the telecom domain. Okay, so I was working with Alcatel Lucent. That the company is now being acquired by Nokia. Okay, so as I said, like from the initial days of my career, I used
So you are not audible, Atul.
I'm audible now.
Yeah, now you are audible. Yeah.
Oh, sorry. I think there might be some network issue. I'm not sure.
No
Okay, yeah.
worries.
So okay, yeah. Okay, so I had an interest in learning new things. Okay, so
Mm-hmm.
learning new things, I mean to say, like back to year 2009 or 10, right?
Mm-hmm.
Cloud was just coming, right? It was not into the market of Indian market, but like it was in there in US and UK, right? Sorry, European markets. So at that time, I
Mm-hmm.
started learning, and slowly, the journey started, right? And
Mm-hmm.
then eventually, I started working on to
Mm-hmm. Atul, again your voice. Yeah.
one second. One
Yeah.
second. Let me check what is the issue.
Mm-hmm.
I'm audible now.
Yeah, yeah. Yeah, good.
Mhm. Okay. So yeah.
Mm-hmm.
Yeah. So yeah. So I started understanding the fundamentals, right? The
Mm-hmm.
fundamentals,
Mm-hmm.
right? Like if your fundamentals are strong, okay, if your fundamentals are clear, you can easily, navigate between the technologies easily, right? Okay. So what I understood was that
Mm-hmm.
if you have a fundamentals clear, if you do
Mm-hmm.
your hands on properly, you
Mm-hmm.
make your hands dirty with the technology,
Mm-hmm.
you will able to
Mm-hmm.
learn it. Okay, and
Mm-hmm.
inspiring, how I was getting inspired was because of, like, I always love to do some cool
Mm-hmm.
things, right? Like in my projects, right, there were new requirements coming every time. Okay, like I was working with different clients, right? Some clients used to say, like, hey, I have this business problem, or I have this use case, can you help me with that? Okay, so I used to do on my POCs, right? I used to do some Google and other things. At that time, YouTube was not that much popular at those days, right, the way it is now. Okay, and in Google also, we used to have a limited information, so we used to navigate into the Google, go to the Stack Overflow, go to some other books, refer to some books, right, articles, or some publications, and based on that, we used to develop some POCs or complete the POCs. Okay, so this was an interest, right, which I used to have, and that motivated me to keep on working on this direction, right? So it depends upon person to person, right? So I will give you a small example, right? in year 2008, okay, while I was doing engineering, I didn't had, I will be very, very honest to you guys, right? Till engineering, I didn't had much interest into the technology, okay, to be very honest, okay. But after completing the engineering and when I got the job, right, there one day one question came to mind, like, hey, how the systems are working, right? Whenever I type a command ls, okay, it will list me the directories or files, how it is working into the back end, okay, right? That made my life changed
Mhm.
at that time. Okay, I started understanding the operating system, how the operating system works, what is the boot process, okay, what are the libraries, what are the packages which are needed, okay,
Mhm.
what are the
Mhm.
inodes, okay, when you
Mhm.
type, computer understands the binary language only. So
Mhm.
all these things mm, uh, gave me an interest, okay,
Mhm.
to work into the technology domains,
Mhm.
right? And same thing I applied everywhere, right? Like if I have any doubt, okay, I don't go on to the high level, I go on to the low level first, okay, I understand the basics first and then start working on anything, okay. So yeah.
Really makes sense. So you start exploring and you are building some things, then how you build an interest. Totally makes
Yeah.
sense. This how the engineer become people. What people do, people mostly focus on the technology, don't focus on the problem. But if you focus on the problem, you learn the technology. I agree.
Yeah, that's right, that's right.
So currently learning JavaScript aims to become a full stack web developer. After mastering Node.js and React, he seeks guidance on where to start learning cloud technology to enhance his web development skills and which cloud topics are essential. Uh,
Oh man. I think if you have that question, can you please paste on the chat? I think I missed,
sure.
yeah, yeah, so that I can
So I
answer
can,
it correctly.
yeah, yeah. So the he's asking about he's learning the full stack developer. So after
Uh-huh.
master, how he can learn cloud?
Okay. Okay. Currently learning the JavaScript, aims to become the full stack developer. Yeah. Wow. Good. Yeah. So full stack developer. Yeah. That is the. I would say that is a very good. Profile, right? So in my team as well, like I emphasize my developers to think like a full stack developer, okay, who can work on the back end, who can work on the front end, who can work on the cloud technologies as well and whatnot, right? So if you want to start, right, if you want to uh, you know start on the cloud, right? First, understand the fundamentals of the cloud. Okay, like why cloud is needed, what is the purpose of the cloud, okay, what sort of capability it gives you to it gives to the business here, right? Like scalability, security, performance, throughput, right? All these are the capabilities, resilient in nature, right? All these capabilities are being provided by cloud platform. And then it's the interest of the person, like they want to go for Azure, they want to go for Google or AWS, okay. All these cloud providers rely on this same fundamentals, okay. Their services names are different, right? Like in AWS we have S3, okay, which is an object storage. In Azure we have Blog, that is also an object storage. In Google we have a Google Drive, that is also object storage, okay. So it depends upon the user which cloud platform they want to go for it. But right now in the industry, AWS and Azure are very much widely used, right? And every business has their own uh, you know rationale behind it, right? Like they do the pros and cons, okay. Using AWS, these are the cons. Using Azure, these are the pros, okay. So they do all these things. Now if you talk about learning the essential topics into the cloud, right? So I will just refer to the AWS now, okay, because I am a big fan of AWS, okay. I'm not against the Azure and Google, but like since I've been working on AWS for a long time, so I will just let you know about the Azure AWS now. Okay, so if you are in machine learning on AI, right? So the right topics or the right services to learn in AWS is SageMaker. Okay, SageMaker is one of them, right? Then is your Glue, right? Lambda, RDS, DynamoDB, and your this thing load balancers. Okay, so these are the few services which are important for somebody who is into the AI, ML, and data domain. So if you master in these services, you should that should suffice your needs as a AI and ML engineer. I hope I answered this question.
Yeah. So the final questions we have is Gen AI and LLM learning is essentials for getting an internship.
Is Gen AI essential for getting an internship? This is the
Yeah.
question, right?
Yeah, Gen AI and LLM, because nowadays these two are the hype word, right? Everyone is talking about Gen AI and LLM. So yeah, that's the final questions we have. Yeah.
According to me, it's not. It's not. Okay. So the reason why is I'm saying is right, like that in India, the things are getting overhyped. Okay. There is a lot of fear mongering going on. Okay. So don't get carried away with that. Okay. Do what is right for you. Okay. Assess yourself. Okay. Every person has their own, talent or skill set. Okay. So don't get carried away with the YouTubers or some, this course selling people. Okay. Cheap marketing
Yeah.
tactics. Okay. Right. Understand
Yep.
the basics first. Okay. Understand the basic first. What are the right basics, fundamentals? Okay. And you will able to get the internship. Right. And also I will tell, do some projects yourself, build some small project. Okay. There are a lot of code available on the GitHub. Okay. Clone that code. Okay. Make some changes on that code, deploy locally, or use some cloud platform to deploy there. Write that in your resume. Okay. Like, hey, this is what I have done. Okay. There are a lot of videos on YouTube. Okay. Go that, learn there. Okay. And definitely you will get an internship there. Okay. And the internship as well, I would say, like an internship also, you don't learn much. Because why I'm saying this, this is see, again, this is my personal opinion. Okay. So
Yeah.
things might be different, but the thing is, like in the companies where you go for an internship, right, you don't get the actual work. Okay. You only get the operational work. Okay. The work which the people don't want to do, they will delegate that thing to intern. Okay. But it's good to go for internship. Why? You get an exposure of corporate. Okay. How things happen in the corporate. Okay. Or you make the connections within the corporate. Okay. But with the learning type, technical learning type, you don't get that much exposure, but you only learn like how things happen in the corporate. Okay. So this is what I would say. So learn the basics. There is nothing, no need of Gen AI is only the ticket to get the internship. No, that's not right. Okay. Do some hands-on, learn the things, learn the basics, learn the fundamentals, and you should able to get an internship.
Great. I agree. Totally agree. So I think I didn't want to end, but unfortunately we have to end these sessions. Amazing sessions. So many questions, so many interactions. Amazing. So we really enjoyed Rajot sir. Thank you so much for having you. So we'll end it by these things. Keep learning, keep building until the next sessions. Thank you so much,
Yeah.
you all. Have a good
Thanks
day or
everyone.
good night.
Thank you.
Yeah. Bye bye.
Thank you.